Welcome back to my Blazor Fundamentals Series, where we're going to look into the Blazor WebAssembly boot process. In this video, we'll take a look at Blazor WebAssembly from the boot process, giving you confidence in what's going on under the hood from the very first request your browser makes. It's going to be super exciting. Let's get to it. Now, one of the key Blazor hosting models for the web is Blazor WebAssembly. Whether you're targeting .NET 9, .NET 8, 7 or 6, composing a meaningful Blazor application that really gives end users the best experience client-side today will involve having at least part of your application utilizing the Blazor WebAssembly hosting model. Now, if we just jump into the docs for ASP.NET Core Blazor, we can see that Blazor is a .NET front-end web framework that supports both server-side rendering and client-side interactivity in a single programming model. It allows us to create rich interactive UIs using C#, share server-side and client-side app logic written in .NET, render the UI as HTML and CSS for wide browser support, including mobile browsers. And it also allows us to build hybrid desktop and mobile apps with .NET and Blazor. Okay, so I just wanted to kind of sound off a few things before we get too deep into the Blazor WebAssembly journey today. And that, as you can see, that I'm currently in the WebAssembly GitHub repo, which is part of the ASP.NET Core repo. As a Blazor developer today, it might feel a little overwhelming when trying to select the right hosting model. We have Blazor Hybrid, PWA, Blazor Server, and Blazor WebAssembly. And this is a little compounded by the fact that we also have a set of render modes now. We've got static server, interactive WebAssembly, and interactive auto, which might leave you wondering where to start. Let me just start by saying, don't worry. All the hosting models are completely relevant today and can be combined to give your application the broadest reach and the optimal user experience. The key is understanding each separately and then combining that knowledge to develop the application that leverages them all. Right now, I'm developing applications that run on iOS, Android, Windows, and the web, all from a single shared code base while utilizing all the hosting models and rendering modes where applicable. Now, one of the reasons for creating this Blazor Fundamentals series is to be able to break down some of these concepts into some manageable chunks. I'll give you an example. In .NET 9, the way that we're heading at the moment with the Visual Studio and Visual Studio Code templates is that you'll do file new Blazor application, and what you'll end up with is at least 3 different project types. And those will be Blazor WebAssembly, Blazor Server, and potentially Blazor Hybrid, all under one solution, which is absolutely fantastic. But it doesn't take away the fact that under the hood, under the covers, we're still dealing for the web, for that target, with Blazor WebAssembly for the client, Blazor Server for interacting directly with the server, with the rendering modes, static for showing some initial UI to the user for them to see that kind of rendering taking shape really quickly. And then moving to the Blazor Hybrid model targeting iOS, Android, and Windows for mobile devices. So breaking apart these concepts will really help you to be able to utilize and get the best out of each of the hosting models, even though they're being wrapped under one umbrella to make an absolutely super development experience. And that's what Microsoft are working towards all the time, to make us super productive, for us to think more about our Blazor components and less about how we actually target the different devices that they all run on. So that's just going to get easier and easier. But right now, today, when you come to compose an application, being aware and understanding how a Blazor WebAssembly application differs from a Blazor server application, and how that also differs from a Blazor hybrid or even a PWA application, will help the way that you write your code and the efficiencies and some of the constraints that arise as a result of each of these hosting models. And that's what this Blazor Fundamentals Series is all about, is to help you now as we move into an easier, better world that Microsoft are creating for us. And incidentally, if you're looking for a video that answers what Blazor is from a high level, I created a video back in 2020, which I'll drop a link to below, which not only explores what Blazor is from a high level, but it also explores both Blazor Server and Blazor WebAssembly in quite a bit of detail, with the history of how Blazor WebAssembly began. So please check that out if you're interested in the link below. So let's walk through the boot process of initializing a Blazor WebAssembly application. Also bearing in mind that Blazor WebAssembly can run entirely in the user's browser, and that's what we're seeing here. We're seeing this application URI in this instance CarRandall Blazor app, and there's that initial request which is being made to the server. And this is very similar to other SPA or single page application frameworks such as Angular or Vue, where everything is running entirely within the client browser. So the process begins with a request from the browser to the web server, as you can see depicted here. And the web server will return a set of files to actually load the application. And you can see that depicted here. So we've made the request, we've had the request returned, and one of those key items that will be returned is our hosting page, which in our Blazor WebAssembly standalone example is our index.html. And then the browser will utilize its capabilities to go request each of the assets that are referenced within that index.html, such as CSS and JavaScript, as you can see depicted here. And as a result of those requests, one of the referenced script files, that's JavaScript files, in the index.html is this blazor.webassembly.js. And we can see an example of that here inside our Solution Explorer. And just incidentally, what you're seeing here is the formation of our migration series with Blazor, where we're migrating an ASP.NET Core MVC application to Blazor WebAssembly, which is a typical scenario for using Blazor WebAssembly, where we can store or serve our files statically without the need for a hosted server. And what that opens up to us is being able to host our files pretty much anywhere, whether that be GitHub or on any static server such as Azure Static Web Apps, which is what this Blazor migration series is focusing on. And if you're interested in learning a little bit more about that, then I suggest you take a look at the video, which I'll pop on the link below. And also, while you're there, it would be good to consider subscribing and liking the channel, hitting that notification bell so that you get notified of new videos and content as we add it. So if we have a look into this index.html, we've got the typical setup here within the head where we're referencing certain assets. We've got some metadata going on here. We've got a style sheet being referenced here, the favicon, and some inline styles. I'll just collapse that head. And then when we come into the body, if we just jump down a little bit, we're referencing some JavaScript files here. We've got a little bit more styling going on. But the bit that I wanted just to highlight is this file here, this Blazor WebAssembly.js that's being referenced here. So the browser, as part of working through these scripts asynchronously, will download this blazor.webassembly.js file. And this is really quite special because part of the Blazor framework, in the case of the Blazor WebAssembly hosting model, actually resides in JavaScript and is contained in this blazor.webassembly.js file. And we can see that depicted here. So some of the key responsibilities that this this Blazor framework JS part, because there's a .NET part which is going to be downloaded and run, which we'll see further down the line in this boot process, but the JS part, its responsibilities are to load and initialize the Blazor application in the browser. It provides APIs for JavaScript interop scenarios, which is something that WebAssembly is not capable of doing at the time of writing this video content. It also enables direct DOM manipulation. So Blazor can essentially perform UI updates. Another thing that isn't possible at the time of writing with WebAssembly, but absolutely key to rendering the results of the download into the DOM. Now we're back in the browser and we've got the network tab open via the Chrome tools. And I thought we'd just go through this process to see some of these requests being made. Now the first request that is made is this localhost, and this is what we depicted in our diagram, where it's our initial request to the server for our host file, which in this case is our index.html. And we can look at the response for that, and there we are. We can see all of the markup, including the framework Blazor WebAssembly.js as expected. And then, as you would expect, the browser starts to parse this file and asynchronously start to reach out to pull down a number of different scripts and CSS files. And you can see here it's got the Blazor WebAssembly.js being one of those files. But what's interesting is what starts to happen once this Blazor WebAssembly.js file actually runs. So we're back into our diagram now, and I think it's important to highlight once more that at this stage our Blazor WebAssembly application has completely downloaded as a set of static files. There's been no server rendering, no pre-compilation, just a download of static assets. Now, one of the key things that the Blazor framework does on the JS side is to request a manifest file, which is actually being depicted here in the diagram. And this manifest that is returned is called blazor.boot.json. So let's have a look at that in the browser. So we can see the request here for our blazor.boot.json. And if we have a look at the response that's returned, we can see that it's a JSON file and that it actually starts to make some sense now into the responsibilities of our Blazor framework as to how it's going to actually completely bootstrap this application. So for the first time, we're actually seeing this main assembly name, which in this case is the name of our application. And then we start to see some .NET native JS files and some .NET runtime and WASM JS files being referenced here. And then what's really interesting is the fact that we've actually got our assemblies that our application depends on referenced here. And they're actually, as you can see here, pre-compiled or AOT or ahead of time compiled in this particular example into WebAssembly, so pre-compiled, which does come at a slight cost in terms of download size, but does significantly increase performance. Earlier versions of this manifest file would actually reference the DLLs, which were then compiled inside the browser. But based on the fact that ahead of time compilation is actually turned on, this is certainly a very efficient way of bootstrapping and starting up the application. So we've got all of the required packages that are required by the .NET runtime and our application registered here, and these will all be downloaded into the browser cache. And we can actually see that if we go into the application tab of our browser and look under the cache storage, we can see that under .NET resources for this URI, our local host for this WebAssembly application, we can actually see these files cached in the browser and pre-compiled to WASM. So this is really where a lot of the magic happens in terms of ensuring that all of these dependencies are downloaded along with the actual runtime itself, the .NET runtime, which is now for the first time going to be in a place to run the .NET side of our Blazor WebAssembly application within the context of a running .NET runtime application. And we can start to see this now being depicted in our diagram. So we've loaded our boot manifest. We've now made a request for the framework, the .NET runtime, and the application files back to our web server. And lo and behold, back comes our .NET runtime, as we saw in those collection of files in our boot manifest, along with our main application DLL, and then all of the dependencies that are required by both the runtime and our application. So once all of these files have been downloaded, including the runtime as depicted here, it's time for our application to be able to be run. The WebAssembly.NET runtime is initialized, which in turn loads the Blazor framework, and finally the application itself. And at this point, we have a running Blazor application that exists entirely in the user's browser. And we can see where the application is first loaded. If we go back to our source code, we just have a look inside our index.html again, we've got this div with an ID of app, which is configurable depending on where we want to load our Blazor application. But essentially, once the runtime loads and the Blazor application is initialized, the content of our application will be injected into this div. And we can see this depicted if we go back to our diagram, where the DOM is updated, our application is running, and then any further data requirements that our application has will be serviced by the Blazor application running in .NET and calling through to JavaScript interop if required, and really going through the life cycle of our Blazor application now. So I really hope that you're enjoying this Blazor Fundamentals series. If there's something you'd like me to cover, please leave me a comment below and I'll be sure to take a look, especially if it's around Blazor or Azure or an emerging technology. So if you like the channel, if you like the content, please like and subscribe and jam that notification button as well to get notified of new content. And I look forward to seeing you in the next Blazor Fundamentals series. Cheers.